Hello and welcome to today's section in further mathematics. In this section we'll be looking at the topic Surds. But before we proceed, I would like us to do a quick review of our previous lesson. Welcome back. Now what is Surds? Surds are irrational numbers. They are the root of rational numbers whose value cannot be expressed at exact fraction. Example of Surds are root 2, root 7, root 12, root 18. We can go ahead and start having root 13, root 23 as you can proceed. But there are certain rules that we use when it comes to Surds. But one thing you need to know is that a Surds must have a sign of a square root. There should be a sign of a square root in the number, so you can say root 23. So there should definitely be a square root in it before it will be able for you to be classified as a Surds. You can't just see 3 and say this is a Surds. No, this is a positive whole number, but you can call root 3 as one of the members of a Surds. So rules for Surds, there are certain rules for Surds. Now when you talk about rules that we use in Surds, number 1 rule says, this is rule number 1, if you have the root of A times B, it is the same thing as square root of A times square root of B. That's number 1 rule in Surds. Number 2, if you have division A over B, is the same thing as square root of A all over square root of B. So that is to say, in this first one, if we have root 16 times 4, is the same thing as root 16 times root 4, which is equal to 4 times 2, which is 8. Now in this other one, if you have root, it's trying to tell us now that if you have root 16 over 4, is the same thing as root 16. Remember, this root is for everything. Same thing as root 16 over root 4, which is equal to 4 over 2, which is equal to 2. The third one here is, if we have square root of A plus B, it's not equal to square root of A plus square root of B. If you want us to prove it, if you check, like at this point, if you have the square root of 16 plus 4 is equal to square root of 20. But is it the same with the square root of 16 plus the square root of 4? Which is the square root of 16 plus square root of 4 will give you 4 plus 2, which is 4 plus 2 is 6. But if you do the square root of 20, you'll be having about square root of 4 is 16. Square root of 20 is less than 5. Square root of 20 is less than 5. So it's not the same. And the same rule applies to subtraction. A minus B is never the same with square root of A minus square root of B. So these are the 4 basic laws that governs Surds. So I would like you to always take a reference from this each time we want to solve questions on Surds. Now we'll go into identifying similar Surds. When are Surds said to be similar? If the root value is the same. We are interested. Remember I said our area of interest is in the square root value. So if we have square root of 5, this symbolizes our level of relationship. So if we have 7 root 5 plus 2 root 5, these sorts are similar because they have the same square root value. This is 9 root 5. But if we have 7 root 4 plus 7 root 2, it's not a similar sort, despite the fact that here and here is the same. Despite the fact that 7 here and 7 here is equal, we don't pay attention to this point, but rather we pay attention to root 4 and root 2. Since they are not the same, this sort is not similar. But if we have a situation, if this was to be 7, if this was to be 4, and even if you change the value of this one to 9, this is a similar sort now, because 7 plus 9 is 16, but the 4 here is constant, so this is 16 root 4. So that's doing about sort. Similar sort must have the same root value. But it is very important to know what a conjugate of a sort is. Now when you talk about a conjugate, it talks about changing sign. So if I have 3 root 4 minus 2 root 6, then the conjugate just talks about changing the sign that is here in the middle, not in front, not behind. So this thing becomes 3 root 4 plus 2 root 6. Simple. So if I say find the conjugate of 2 root 9 minus 2 root 9 plus 4 root 6, the conjugate, remember, we don't touch the sign that is outside. Our interest is just the sign in the middle. So this is still minus 2 root 9. You change this to minus 4 root 6. That is it about conjugate of a sort. So let's just go into solving some few questions. Let's call this our example. Example 1. It says simplify root 45. I root 45. I root 98. And let's say I. We have 7 root 3 minus root 75. Now we are solving these 3 questions. Let's go to the first one, or we call it the value of here. Let's use the word A. That's for the first one. Now root 45 is the same as root 9 times 5. Now according to our law, it's the same thing as root 9 times root 5. Since 9 is a perfect square, that gives you 3, and we have 3 root 5, since 5 is not a perfect square. That's all for the first one. Now let's go into B, the second part. Root 98 is equal to, we now have 98 is the same thing as 49 times 2. Root 49 times 2. And according to our rule for sort, is root 49 times root 2. But remember, root 49 is 7 times root 2. So our value is 7 root 2. This for 48. Then what then happens in the process where we have that is the C part of it, which is this 7 root 3 minus root 75. So this is 7 root 3 minus 75 is the same thing as 25 times 3. So this is 7 root 3 minus root 25 times root 3. Remember, this minus is for both. So you now have 7 root 3 minus root 25 is 5. Then we have here root 3, since we cannot do that of root 3. So this is now 7 root 3 minus 5 root 3. So 7 minus 5 is 2 root 3. So the value for 7 root 3 minus root 75 will give us 2 root 3. I'd like to say a very big thank you for being a part of today's lesson. Now, in order for you to refresh your memory in what we've just discussed, I would advise you take the test that will be popping up shortly on your screen. Do well to give us a feedback, your comment, your recommendation on our comment section. We'll be looking forward to having you in our next lesson.